This conference will now be recorded.
Hello, everybody. Jordan Groth here with the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 191. The title of today's presentation is Introduction to Ship-to-Ship Lightering. The presenter, Captain David Boudreau, Master Mariner and industry expert in tanker lightering. I think this is the first presentation we've had on this topic. Should be a great one. Our discussion following David's presentation will be from Joe Sinkowitz, Ocean Prediction Center Ocean Applications Branch Chief. Just a few reminders before we get started. As you just heard, this session is being recorded. As always, there will be Q&A after the presentation. Please post your questions in the chat. Please specify your full name when asking a question in the chat. If you are signed in with an office account, please remember to mute your microphone and turn off your webcam otherwise. We're always looking for future presenters. Please contact the TOWR-S team if you are interested in presenting. And the training team can help create training materials that may be unavailable. Contact Ross Van Til for information or questions on that. I'd like to thank our Office of the Chief Learning Officer, GOZAR JPSS Programs, our presenter, facilitator, and all of you for being with us today. Without further ado, let me introduce Captain David Boudreau, who graduated from the California Maritime Academy with a third mate license and degree in maritime transportation and logistics. He sailed with Military Sealift Command MSC for 12 years, working his way up to master of one of the newly built TAKE class ammunition supply ships. He left MSC to explore new opportunities as a salvage master for a few years. Looking for more stability and time home with family, he has spent the last 10 years as a mooring master conducting ship-to-ship lightering operations in the Gulf of Mexico, as well as the Atlantic coasts of Brazil and Uruguay. He recently was brought shoreside as head of lightering for one of the top lightering companies in the world. So, looking forward to his perspective today. David, welcome to the Satellite Book Club.
Thank you very much, Jordan. Appreciate that. Thank you for the good introduction too. So welcome everybody. Thank you for having me here. So we're going to talk about ship-to-ship lightering today. There's a couple different types of lightering operations that can be done. There's something that we call in the industry a standard lightering operation, is when the VLCC comes in loaded from either Saudi Arabia or somewhere else, and then we use some smaller vessels to take all of that cargo off of that. We used to see this one was the predominant one here in the Gulf of Mexico that we used to see a lot of, and most of the operations were what we called a regular lightering operation. Around 2015, 2016, we saw a shift in this as we started to do more exports in the US. As we did more exports, we started to see what we called a reverse lightering operation, which is where the VLCC is empty and we're loading the cargo in port onto the smaller tankers and then bringing it out to the VLCC and filling the VLCC up so she can take that cargo to other locations in the world. The other one is the one we saw in the video, where you have like the dynamic position shuttle tanker, which is a special vessel. It's too expensive to have that vessel transit all over the world carrying the cargo. So instead, they'll take the cargo off of that vessel so that she can continue to do the work that she's supposed to be and designed to do, and put it onto other vessels to take and transport across the world. And then, of course, there's also the ones where the vessels are carrying cargo from multiple locations, commingled, and then that has to be distributed to different ports, so they'll take that cargo off little by little. In 2023, there was approximately 6.99 million barrels of U.S. crude consumption. In the U.S. Gulf, we did approximately 1,319 STS operations were conducted. 750 of those were reverse lightering operations, and approximately 550 of them were standard lightering operations. There's some regulatory framework that governs ship-to-ship lightering. The international treaties, MARPOL. MARPOL also dictates what the POAC or the mooring master qualifications they have to be a mooring master or a POAC. Then there's STCW and SOLAS. Industry groups, the main one that everybody follows for ship-to-ship transfer operations is the OCIMF. Tankers, guidance, STS guide for conducting ship-to-ship transfer operations. It's basically our Bible for being able to do ship-to-ship lightering operations. Intertanko talks a lot about the cargo transfer itself. ITOL is the industry task force for offshore lightering, which came about in the late 80s when ship-to-ship lightering was becoming more and more prominent in the Gulf of Mexico. And the Coast Guard came and started approaching the oil majors and the STS providers and asking them how they were being regulated and how they were making sure that everything was being conducted safely. So what got put together was the Industry Task Force on Offshore Lightering here in the US, which I'm co-chair of. And what we do is get together every year and present all of the near misses and lighter incidents and any lessons learned and everything from all the operations. We talk about how we can improve STS in the Gulf of Mexico and the U.S. And what things we can do going forward. It's made up of the shipping companies, the Coast Guard, the oil majors, and then the lightering service providers, which there's 3 here in the Gulf of Mexico. EMEA is the European version of ITOL, and that same thing, they're made up of the lightering service providers over there, the oil majors, and then some of the regulatory bodies over there. And then, of course, we got SOLAS again as well. Flag state regulations, different locations. The U.S. Gulf is governed by the Coast Guard here. They have a few things, just mostly notification stuff. South America, Brazil and Uruguay, we actually have to get licenses and permits. And we actually have to have a license to be an STS provider down there. And then they require us to also be the oil spill response providers as well. Every operation requires 2 tankers, either VLCC, Suezmax, Aframax, or Panamax, or even smaller. There can be Handymax or MR-sized vessels as well. We need 1 lightering support vessel to carry the fenders and the gear, wire tails, hoses, and personnel. You need a qualified mooring master who is the person in overall advisory control, and that's a key point to remember that they're only in advisory control. They're very similar to a pilot in that instance. They come on board, they'll take the con and maneuver the vessel, but they don't actually have any responsibility for the safety of the vessel itself. The master and the ship's crew retain all the actual responsibility for the vessel, but the mooring master's overall advisory control of the entire operation. We also have assistant mooring masters who help with the hose connections and the line handling and helping to make sure the crew are trained and familiar with how to do things. And then, of course, you have to have the shore-based support who supports the lightering support vessels, maintains the gear, and then finds the operations. So from a commercial perspective, how this works is customers will come to us and give us lightering nominations and tell us how many operations and how many vessels they're going to have coming in that are going to need to be lightered for a month. We'll start to put together a schedule. We'll do the ship-to-ship transfer suitability and compatibility, which we'll go into here in a little bit more detail. Then we'll do operational checks and pre-arrival information gets sent out. Notifications or permits or license will get gathered, and then the operation itself will be scheduled and conducted. Safety and compatibility, we do a lot of pre-arrival and pre-approval checks. One of the things that's come out, especially since the Russia-Ukraine war, is the sanctions checks for what cargo the ships were carrying previously, and if they'd gone into any of the sanctioned ports or carrying any of the sanctioned cargo. So we have to check for that and make sure that none of that's happening and that we're not working with any vessels that have carried sanctioned cargo before. The picture you see above this here, right here, is what the ITOL questionnaire, the Industry Task Force on Offshore Lightering put together this questionnaire to help with screening and suitability checks. It has over 213 questions that we ask to check on various things from how old their lines are for mooring, what types of lines they have, if they'll do basket transfer, what's their crane outreach, what's their minimum speeds and maximum speeds, and where critical RPM ranges and everything, and then sizes of the vessels and basically ship particulars and everything. From these things and getting the general mooring arrangement, we'll put together the mooring diagram that you'll see in the bottom here. The mooring masters do this. We do preliminary ones from the office, but we just have to make sure that they're going to be able to take the correct number of lines that we need them to take, and that they'll be suitable and capable of conducting STS alongside. Communication is key to successful lightering, and that communication has to flow in all directions. It starts in the office, obviously, with assigning the jobs and doing all the pre-arrivals and making sure everybody's going to be on time to where they need to go. Then the mooring masters, once they're on station, coordinating with the vessels and maneuvering the vessels and figuring out rendezvous positions, and then feeding back ETAs and ETCs to the office. And then when they're conducting the operation, cargo checks, flow compatibility, making sure when the operation is going to be complete so we can get to the next operation. And then, of course, after the operation, any lessons learned and any incidents that we have to go over and discuss. There's 5 checklists that OCIMF puts out that we're required to go through. STS checklist number 1 is basically a ship's particulars checklist, which OCIMF has actually allowed the ITOL checklist to substitute, so we do substitute that. Checklist 2 is going to be once we get all the gear out and all the ships are ready to conduct operations, then we say we're ready to start operations. Checklist 3 is for before we put those vessels together, as you saw in the video, the last time before they're going to go alongside the fenders. Checklist 4 is for everything to do with the cargo operation itself, and checklist 5 is for before we separate the vessels. So step by step, you saw in the video, we got to deploy the equipment. There's going to be a pre-lightering conference on station. They'll conduct their approach, the mooring, the cargo transfer, and then the separation, and then the retrieval of the equipment. And this is a very circle of life type thing, because this constantly goes on. Here in the Gulf of Mexico, there's approximately 60 to 80 operations going on a month. So there's generally always an operation happening each day, unless the weather is preventing us from conducting safe operations. So all of the workboats and all the personnel are constantly going in this cycle while they're doing operations out here. Once the mooring masters get out there and they're doing their communications, they're going to start communicating about 48 to 72 hours before the ships arrive. They'll be giving them rendezvous positions, talking about the mooring plans. They'll go over a joint plan of operations, contingency plan, and then discuss who's going to get which type of equipment, because we can put that primary fenders on either vessel. We can put the hoses on either vessel, so they'll just discuss there and make sure that everybody's on board with the plan. The equipment that we use, we consider our lightering support vessel a piece of equipment, and we make sure that's maintained, because we can't get the gear out there if the lightering support vessel's not working. So there's 4 type of size fenders that we use. For primary fenders, we have a 4.5 by 9 meter fender, which is called the standard jumbo fender, and a 3.3 meter by 6.5 meter fender, which is a standard smaller fender. 4.5 meter 6 by 6.4 meter is what we call a jumbo ball. It goes in between these two. The difference between the jumbo fender and the jumbo ball is only about 600 to 800 pounds of compression, so they're very close, so we can actually use the jumbo balls for most any operation that we have. The nice thing about the jumbo ball was it's actually just about the same length as a standard fender, which when we were doing all standard operations, we had this size fender, and the boats were all designed to this size fender. So in order to be able to still carry 2 sets of gear, the jumbo ball makes it nice, because we can actually put 2 sets of jumbo balls on board the boats now because of the length. Secondary fenders are these little tiny fenders that you see up here in the picture. We call those baby fenders. They're 1.5 meter by 3 meters. As a mooring master, you never want to have to use them, but they're there if you get out of alignment and you have to use them. They're the extra little protection. Hoses, we use Yokohama. Most everybody uses Yokohama grade hoses. They're 12-inch by 26 meters long. 15 bar maximum allowable working pressure, 25,000 barrels per hour each as a flow rate for each hose string. So up here in the Gulf of Mexico, 2 hose strings, we can get 50,000 barrels per hour. Down in South America, it's very rare to see 75,000 barrels per hour just because once the volume starts going down, that changes the pumping rates. So generally you get between 70 to 72,000 barrels per hour in South America with 3 hose strings. The wire tails and the grommets, wire tails are 1.5 inch, they have 210,000 pound breaking strength. High elasticity grommets are 2.5 inch by with a 320,000 pound breaking strength. We transfer the people by basket. I'll show you a video of that in a minute here. Personnel basket, 4-person capacity, fitted with a shock cord stabilizer for safety. Down here you can see how we rig up the moorings. So you have the mooring wire itself, you have a soft tail or the high elasticity grommet, and then you have the wire tail. You want to make sure that that soft grommet doesn't go in the chocks because you'll chafe right through it if during a dynamic operation there with both vessels moving. Most of the companies do their own in-house testing. Fender relief valves on the fenders are tested every 2 years. The hoses are tested every 6 months to 1.5 maximum allowable working pressure, and then 4-year service life on theirs. The wire tails, they're visually inspected before every use, and then they have a 2 to 5 year cycle depending on if they're on the vessels, on the ships that we work with, or if they're on the lightering support vessels. The lightering support vessels do more operations than the ships, so we have a 2-year life cycle on the ones that are on the lightering support vessel. Personnel basket is visually inspected before each use and has a 2-year service life on it. Here's a little video for the safe embarkation of personnel. There is some question out there on whether the basket transfer is safer than a pilot ladder. And ITOL did a 6-year study. From 2018 to 2023, there was approximately 7,300 lightering operations conducted. And out of that, there was approximately 32,000 basket transfers. 0 incidents or injuries from the basket transfer. In that same time frame, there was approximately 1,200 pilot ladder operations, and about 3% of those 1,200 resulted in some sort of incident, injury, or near miss, and 28% of that 3% was high potential. Somebody's life came very close to being in danger, so and being hurt or killed. So it's to me, the statistics speak for themselves. I was a salvage master. I've boarded vessels in a lot of different ways and a lot of different conditions, and I'll take the basket any day of the week and twice on Sundays because it's much safer than anything else. And as you can see, they lift them up. You do stand on the outside. You do not want to be on the inside. I get that question a lot because if you end up going in the water, you want to be able to actually get out of the basket, and you don't want to be tangled up inside the netting there. So generally the luggage and stuff will go inside the netting and the personnel will stand on the outside. How we deploy the fenders. So this is the back deck of the lightering support vessel. Up here forward, we connect a wire to the ship's wire on their mooring winch. And then this is a high elasticity stretcher line that we put in here to save the fender netting. Once they have it in position, you'll see a little marker here. They get lined up, they set the brake, and then they'll slide it off the back end of the lightering support vessel. And they'll do that with each fender once everything's in place. And there's intermediate wires between each one. Like I said before, you can either put this on the maneuvering vessel or you can put this on the constant heading vessel, depending on what type of operation you're doing and the size of the vessels and everything. Deploying the moorings and the high elasticity grommets. There's a little bit closer view here. So they're going to come and connect them up. We connected shackles to the lines itself, and then the wire tails are going to go on the end. For most operations, we require 18 lines. That's 8 total head lines, 2 forward spring lines, 2 after spring lines, and a total of 6 stern lines. The minimum number of moorings we'll go to is 14 for any STS operation. After all of the gear is in place and all the wire tails and the grommets are in place, then that's when we'll call checklist number 2 and say that we've commenced operations. From there, we'll start maneuvering the vessels. You want to come in from behind the stern of the constant heading vessel. We'll put one vessel on a course and speed. Generally, we do these at about 5 to 5.5 knots. Once we have the one vessel on course and speed, we bring the vessel in from the stern of the maneuvering vessel. We'll parallel out about one cable off, get in position, match our speeds, and then we'll be able to call checklist number 3 and start putting the vessels together. When you're putting the vessels together, you're going to give about 2 to 5 degrees of heading change to start closing that distance between the two vessels. Meanwhile, you're monitoring the course over ground and the speed over ground, and that's going to tell you how fast the vessels are closing with each other, and that transverse lateral closing distance. And then after that, the biggest thing is trying to make sure that you land on all 4 fenders evenly if you can. All the compression calculations for the fenders is actually for one fender. So as long as you distribute all of the compression between the 4 fenders, generally you're never going to pop a fender or damage a fender, and you can put both vessels together very safely. So if you do get out of line, like I said earlier, you have got your baby fenders there to help protect you. They go on the extreme parallel body lengths of the maneuvering vessel usually, and then they're there if you get a little bit out of alignment. They give you that extra little bit of protection. You want to try and keep your closing rate down below 0.2 meters per second. That's generally about the speed that's really the safest. I've done it a little bit faster. It's not as comfortable to do it then, but as long as you keep around that, you're in pretty good shape. After we're alongside the fenders, then we're going to start deploying the moorings. We'll pass heaving lines over to pull over the messenger lines and start heaving the mooring wires or the mooring lines over between the two vessels and connect them up. The forward gang will start on the bow, and the after gang will start at the forward spring. Then the after gang will move to the after spring, and then they'll move to the stern. The longest leads you have to pull over are generally the headlines, so it usually takes them a little bit longer than the after gang to get all the lines out there. So that's why the after gang gets to move between all the locations. And most of the time what happens is by the time the bow's getting done is about when the stern crew is on the last set of stern lines on the stern. The transfers can be done at anchor or underway. Most of the time up here in the Gulf of Mexico, we'll go to anchor as long as the weather's suitable. Like I said, down in South America, most of the time we're drifting. A lot of that's because of the size of the box, and then also the depth of the water off of Brazil most of the time is too much for us to actually be able to drop the anchors down. But our standard practice is if the winds reach greater than 25 knots, everybody picks up anchor and starts drifting anyways. After that, the cargo transfer is going to happen. The 2 tankermen PIC of both vessels will start conducting their discussions and pre-cargo transfer conference. They'll go through the Declaration of Security, Ship Shore Safety Checklist, and go through Checklist 4. They're going to decide on what the flow rate's going to be, how much is going to be transferred, and then how often they're going to do their checks. Usually it's hourly, as most people require an hourly check of the flow rate, so you know how much cargo is being transferred and how much cargo is left to go. I get asked a lot why the hose has a catenary in it, and one of the reasons you don't want the hose stretched is, as you can see from this video here, the vessels are constantly moving, and so if you get too much freeboard and too much rolling, you'll stretch those hoses, and you definitely do not want to part a hose because that'll put oil in the water. So you want a little bit of catenary. The hose lengths are designed so that you can offset the vessels by about 5 meters with the manifold, and the hoses will still reach as well. During cargo transfer, the mooring master and the mooring master assistant are monitoring all the moorings, and they're also monitoring the fenders to make sure there's no damage there or the wires don't part in between. You can see the vessels moving and the high elasticity grommets and the wires doing what they're supposed to be doing to keep the vessels alongside. After the cargo transfer is complete, now we have to drain and disconnect the hoses. The primary method for disconnecting the hoses would be to disconnect one end and drain that hose to the other side, usually the lower sided vessel, depending on which one was taking the cargo and which one was giving the cargo. Um, However, when the freeboards are nearly the same, that sometimes can prevent the cranes from being able to lift the hose up, as you see in this video here. So when we have that issue, then we'll do something we call the horseshoe method, which is where we pick up the hose from the center and have it drain to each side of each vessel itself. And once we have a good proper drain, then we'll be able to disconnect the hoses and make sure that they're all clear of cargo. When we're letting go, so here you can see our wire tail. So on the end of it is a high elasticity endless sling, HMPE. So they connect up this quick release toggle pin by cow hitching it in with the messenger line. They'll heave this up to take the slack out of it, or to put some slack in it here so that the person can come take the endless sling off the bits. And then once they have that, they'll slack down the messenger line. And as they do that, this line here will go taut and pull that pin out and release the wire tails. This is for safety so that nobody has to be in there, nobody has to be holding a chain stopper or anything, and they can quickly release the lines without putting anybody in danger. The endless sling on here was not always the practice. It used to be just one big wire eye, but what we found was that that was hurting people's backs, and you needed 3 or 4 people to actually lift it up and put it onto the bits. So we actually came up with this design that's used pretty much in the whole industry now, of having this soft endless slings on there that everybody can just pick up with one person. Emergency response, we have contingency plans for just about every emergency that you could have. And so you're going to see in this video, actually the head wire is going to part on the fenders after they landed. And you'll start to see these fenders come falling back actually here in just a little bit. But we cover fire, oil spill, gas accumulation, emergency separation, any medical emergencies, and the contingency plan also covers loss of communication. So if either vessel does not answer the radio in time in a certain set period of time, we'll call an emergency and abort operations as well, because good communications is essential. So the head wire is parted in the video, the fenders are coming back, and so they're going to have to separate the vessels because you don't want to keep them together with a broken head wire. This is very rare, but it does happen sometimes. So let's talk a little bit about weather parameters. 33 CFR dictates that we are not allowed to berth or moor the vessels, to bring the vessels together, if the wind velocity is 30 knots or 10-foot seas. However, you can put the vessels together when it's lower than that, and it can still reach that amount, and you can still conduct your operation. So they have a maximum allowable limit where you have to actually separate the vessels and stop all operations, and that's 44 knots and 16-foot seas or 5-meter seas. Most everybody does have the rule that if the wind speed reaches 25 knots or greater, you're going to pick up anchor and you're going to drift, and you're going to stay drifting for the entire operation. Visibility is also something that we look for. If we don't have at least half a mile visibility, we will not put the vessels together either. Most of the operators in the Gulf of Mexico use two weather forecasts, one from Weather Ops and one from Storm Geo, but we encourage all our mooring masters to use all available sources, including NOAA and Windy and Weather Underground, whatever they can use, buoy weather, to try and make sure that they're getting the best weather conditions they can, and that they have the best idea on what the weather is going to be like for the operations, so they can make sure they conduct them safely. We also monitor all the tropical threats coming into the Gulf of Mexico, and we'll do that usually with weather ops and NOAA's tropical weather analysis as well. So earlier I talked about the freshwater layer, and so satellite products, this is probably one of the biggest satellite products that we like to use, the Coastal Watch data portal, because we want to actually be able to tell how much fresh water is in the water in the Gulf of Mexico. So what happens generally is you get all the freshwater runoff down the Mississippi River here, and any operations going over here, you see there's a lot of fresh water coming out. So as the snows melt during the spring and early summertime, and then during the fall, you'll get a lot of fresh water injected into the Gulf of Mexico, especially with all the rains as well. You'll get a lot of that fresh water, and that fresh water will sit on top of the salt water, and then you'll actually have two layers of currents. So the freshwater layer will actually be going in one direction, while the saltwater layer can actually be going in an opposite direction. So you can see how that might pose some problems when you're trying to put two vessels together with different drafts. So the deeper vessel will be affected by the saltwater layer, and the higher vessel will be affected by the freshwater layer more. And oftentimes what happens is it prevents you from being able to put the vessels together, actually, because that freshwater layer will be in the middle between the two vessels, and as you get closer and closer, you essentially hit a boundary wall that slows the vessels down and doesn't always allow you to put them together. So you can do a few different things. You can try and find deeper water. We can look at these satellite images and say, hey, where's less fresh water? And we can go try and find that. We have a saying, if the water's green, it's mean, which means that it's not going to be nice to us. So we want to find blue water. Sometimes, depending on the drafts of the vessel, it's actually better to go to the shallower water. And then oftentimes you can disperse that fresh water by speeding the vessels up, but you also have to watch out how fast you go, because most of the time the fenders don't like it when the vessels are going more than 6.5 knots. So you try and keep below that when you're considering increasing your speed to put the vessels together. And then also trying different headings, because sometimes different headings will work better for you. And that's the end of my presentation. Joe?
Yeah, thank you, Captain. Appreciate it. Invite people to submit questions using the chat. Also, if you could go to the top in the middle of the screen and click on active cameras, for those of you who are going to stay on, go ahead and do that. And that way we can, yeah, go ahead and do that. Before we go to questions, and go ahead and submit, and I just pulled the chat away. Please, next week, basically Thursday, May 30th at noon, again, will be Chris White, Applications Integration Meteorologist with the Weather Service Forecast Office in Huntsville. And we'll be discussing a deeper dive into the split window imagery. And also reach out to the TOWR-S team, to Kashad or Emily for questions about the Satellite Book Club or for configuration of satellite products. So going to go right into discussion for those of you who have questions. And so far I don't see any, but I'm going to ask a couple. And thanks so much for the talk and the information. I'm not so sure the term lightering, has been around for a very, very, very long time, but this particular brand in the modern era, what impresses me is the rigor, not the rigging, the rigor, basically, of bringing two vessels together, checklists, discussions 2 and 3 days ahead of time. So you mentioned about the conditions, and you also mentioned about, emergency breakaway, and Gulf of Mexico is somewhat known for its thunderstorms and convection. And so I'm going to ask kind of a combination question of emergency breakaway and thunderstorms, and perhaps a sea story. So I'm going to throw it to you and ask.
Okay, so yeah, well, thunderstorms. So generally, our rule is if a thunderstorm, if we see lightning within 5 miles of the operation, then we're going to stop the cargo transfer. It doesn't necessarily mean that we're going to separate the vessels, but it does mean that we're going to stop the cargo transfer and shut the mast risers so that we're not putting any of the fumes and the H2S and the out there for to be ignited by the lightning. So most of the time we'll wait for that to pass, and once it's 5 miles away, then we can get started with operations again. I was actually out there in the Gulf of Mexico when the storm that capsized the Secor Power. I'm not sure if everybody remembers that, but I was actually out there conducting an STS operation when that happened. The constant heading vessel was a Suezmax sized vessel, and I was on an Aframax, and it was a standard lightering operation, and we were down to 2,000 barrels left to transfer off the Suezmax when the storms hit. Luckily, I had made a decision to pick up anchor and start drifting before it ever came. We started seeing some winds increasing a little bit. I'm like, yeah, let's just go ahead and pick up the anchor and start drifting. That kind of saved us in that operation because once everything happened and it went up to 65, 70 knots, then it became really difficult to keep the vessels from moving. And the Suezmax was so light that the seas were actually causing her to roll up on top of the fenders. And at one point, we thought she was going to come actually up onto our deck. And so we stopped. We called the emergency. We sounded the emergency signal. And we started disconnecting the hoses. We didn't even bother with draining them. We just disconnected from the high side and put down on the low side, and then I actually had to get both vessels moving about 6 knots of headway before I could actually get them to separate because I didn't want to turn. Normally, you're going to start turning the vessels to port until that wind starts to come around the bow, and then you use that to help separate you. But at 65 knots, you don't want that to come around the bow because it's going to zipper your vessel apart, and you don't want to zipper the vessels apart because you don't want them to separate too fast. Because as that angle gets bad, then you're going to hit your sterns together. So yeah, by getting it going forward about 6 knots, then I could actually create the pressure wave in between the two vessels and just kick the bows out a little bit and let that pressure wave come in and help take us apart there. So that's probably one of the most pucker factor moments that I've ever had with separating vessels was that, and I was a salvage master, so that's to say a lot too.
Yeah, I reading your your CV was yeah, you've kind of seen and done quite a bit. Appreciate that. I like your second, I think it was the last slide about the fresh water, and the interaction. Something that I think most of us don't appreciate is that separation. Although in the tropics at low latitudes, fresh water is becoming more important because of there is a relationship between a freshwater lens and rapid intensification for tropical systems.
Yeah.
So, but SMOS and SMAP, I took some notes and familiar to all of us, the acronyms, and the basically, satellite derived data. So you're looking at this is from a couple, you've got a couple of different layers in there, but salinity, which is a challenging parameter to determine. But a lot of work went into this, internationally in order to be able to have the capability. Because years ago,
sorry, go ahead.
Go ahead.
So that's actually that's one of the interesting things about this. So NOAA used to have the biggest way we used to tell this was actually from the chlorophyll content in the water.
Yeah.
Because chlorophyll doesn't live in fresh or in salt water. So the higher the chlorophyll content, then the more dense the chlorophyll content was how we would be able to actually tell how much fresh water was out there. But now with the salinity mapping, that kind of helps a lot more, and that's why I layered both of them there. But the chlorophyll is one of the biggest things that we monitor is how much chlorophyll is actually in the water because that actually tells what the saltwater content is.
And you'll be happy to know in the next series of geostationaries, a chlorophyll instrument is being discussed.
Oh, really?
So
Very
because
nice.
there are many. Well, for us, it's also a tracer for current. So not
Yeah.
only that, we convergence and also you will see highlighted ocean features. So something that we're looking forward to, especially with a frequency from a geostationary satellite.
Very
I
nice.
don't see, unless I'm missing something, I don't see any questions in the chat. I'm going to ask Jordan.
That's pretty
And
good.
yeah, you did a great job. I was writing notes to barrels per hour. I don't think people appreciate 25,000 barrels an hour is a pretty damn good rate.
It's a very
Let's say,
significant rate.
yeah, yeah, yeah.
When you consider
Jordan, tell me.
we're moving like the 1 million barrels, that usually takes about 24 hours to transfer all of that with so 1 million barrels in 24 hours. So
Yeah, it's phenomenal. Time-wise, Jordan.
Yeah, if I could ask just one question before we wrap up, because we should let folks get back to their shift. But Captain, thank you for your presentation. Just curious about, I mean, you talked about the types of weather briefings you get. Obviously, there's other internet sites. When you're in the process of going through this operation, are there, and let's say the weather conditions start to change, is there maybe deviate from the forecast? Is there a certain set procedure that folks do to make sure that that everything is still remaining safe and within the guidelines that you outlined within the CFR?
So it's constantly being monitored, and we get the weather forecasts every 6 hours for here in the Gulf of Mexico. But that's why we also so we're putting Starlink on all our lightering support vessels so that we can have more bandwidth to get real-time weather, because that was always when I started doing this 10 years ago, there was hardly any internet on the workboats or even the ships at the time. So you got a weather forecast, and that's what you had to rely on for the rest of the time that you were out there. And it sometimes it was old, and sometimes it's definitely not accurate, but so we're constantly monitoring it, and they're looking at different products. And I presented at the OTC workshop, and then when they gave us some more of those products, I actually shared them with all my mooring masters as well. For that, so they could use some of those products as well, because I found those very helpful too. So it's a constant monitoring thing. We're monitoring it here in the office and feeding them information, and then they're telling us what the actual conditions are out there and letting us know that, hey, it's not matching up with forecast. And so it's a big reliance on what they interpret and what they are seeing out there. And so most of the time we actually have to have them out there to be able to tell if it's all matching with the forecasts.
Thanks, Captain. I have one question: is are lighting operations done by IDA? Are lighting operations done by other nations in other parts of the world?
They are. The Asia has a big lightering, a lot of lightering operations going on over there, especially off of Singapore and Thailand. And then there are other areas. It's you have to watch out, because it doesn't happen like in the open waters and the open oceans. You're generally nearer to a coast. We call it offshore. The Gulf of Mexico is really nice because it's pretty well protected. So most of the time you don't get long swell periods. But synchronous rolling period for an Aframax tanker is 8 seconds. So if your swell period gets to 8 seconds, you'll actually see that Aframax start taking slamming rolls, and it'll go back and forth. And I've been on the workboat where I could look at the Aframax tanker and actually see the other side of the Aframax tanker when she would take the roll, and that's very impressive to see. Yeah, so you're talking 45-degree rolls sometimes. So you don't want to get into synchronous rolling period, that's for sure.
No.
But they're doing it up in the North Sea and Mediterranean, and yeah, it's all pretty much all over.
All right, thanks. And I had the pleasure of being in actually off of Singapore back in November and got to see lightering, kind of all over the horizon. One last is just a comment from Steve Coffidi. Steve basically just did a review of the 2021 Seacorp Power, the conditions, the weather, and I'll just read his statement here. Is the factors involved with strong sustained winds in that event was so localized and difficult to anticipate your actions that that day were very well taken. So yeah, we do after actions too. So
yeah, it was interesting that day because there was three of us doing lightering operations out there. One was a little bit further to the southeast, and then one was closer to the coast, and then I was the closest to Louisiana, and we actually saw it, and like that one called and said, "Hey, I'm starting to see this," and then that one saw it, and then but we got the worst of it being closer to Louisiana. That was actually where the strongest winds were. They didn't get the high winds like I'd gotten it where I was, and so I can imagine where the Seacorp Power was being even closer to that coast there.
Yeah. All right, I think we're out of time. So
no problem.
Great job, Captain. Thank you.
Thank you very much. Thank you for having me, everybody. Appreciate it.
Yep, thank you so much. And please join us next week, Thursday, May 30th, as we continue our Satellite Book Club. We're going to have a deeper dive from Chris White at WFO Huntsville, talking about split window imagery. So hope you'll be able to join us. In the meantime, if you have any questions about the Satellite Book Club or the configuration of satellite products and AWIPs, please contact Rashad Bowman or Emily Maddox. Their email addresses are there on the screen. Or you can find us on Slack, the TOWR-S channel. We're willing to help, so please feel free to get in touch with us. Thank you so much, Joe, and thanks again, Captain, for that great overview of the lightering process. I learned a lot. I don't think I'm ready to lighter vessels yet, but maybe someday.
Take some skill.
Yeah, I'm sure.
Take some practice.
That's fascinating, and please let us know how we can how NOAA could serve you better. I know you've talked to this group, talked to other parts of NOAA, that you've explained those operations quite well, and we're always willing to have a listening ear to how we can provide better products and services to help these kinds of operations that advance American commerce. So thank you so much for your presentation.
Thank you very much.
Yep. All right, with that, we'll wrap it up. Appreciate everybody for hanging on a little longer today, and we'll see you next week, 12 noon Eastern Time. Please have a restful and reflective Memorial Day weekend. Bye-bye.